Today we invited Wayne Gilmore, who is the Executive Director of Research Computing in BU's Information Services and Technology, IS&T. So Wayne's group deals with every aspect of research computing. They have support tools and stuff that can provide support on computation, storage, bandwidth, visualization, data science models, a variety of different functionalities. And also Wayne's group is responsible and running, he's part of the BU team running the MGH PCC. So that's the mass high performance supercomputing cluster where BU has a lot of servers, and some of you may have used these servers, and some of you, I'm sure, will use the servers in the future. And he's also very much involved in the Mass Open Cloud Alliance, so developing tools that would enable research teams to have more accessible and better for their needs access to the cloud. So with that introduction, we're looking forward to, I guess, an overview of what research computing can offer.
And thank you to the Institute, and thank you, Giannis, for having me here today. And we have a small audience, so feel free to ask questions while I present. And as Giannis was alluding to, I'm here to provide an overview about what research computing does and the different areas that we function in, and describe different services that hopefully will be useful to you in your research and studies and to faculty as well.
And also, let me also say that this is a hybrid event, so there are people online, and if there are questions, feel free to post them in the Q&A section, and Rebecca is monitoring the Q&A section, and she will bring those questions forward to you. You don't have to mind. We'll do it.
It's my share here.
Okay.
There we go. Okay, great. So I wanted to just an overview of what research computing provides to the university community. So Research Computing Services is underneath the Information Services and Technology, and we provide centralized resources to both the Charles River campus, the BU Medical Center campus, Wheelock, the entire university, and the researchers that are there. And we have four core components, really, is providing computing. So I'll talk about the infrastructure that we provide and where it lives. Consulting, so we have a whole team of subject matter experts that'll work directly with researchers or with postdocs and graduate students that are doing research to help them do programming, optimize their workflows, and use the cluster effectively, the shared computing cluster, which I'll describe in a bit. We also support academics. So there's more and more courses that are requiring advanced computation, and we're trying to address this need by also supporting courses of students on the shared computing cluster as well. And then finally, we have a very robust training program where we offer trainings throughout the year and video recordings as well. You can find us at rcs.bu.edu. And I have these QR codes for people that want to get more information as the slides go on for specific pages. But everything that I'm going to show you today is accessible off that website. So we're within a whole ecosystem of units that support research, and I just wanted to highlight a few here. So we do a lot of work with the Prairie Institute and specifically the Mass Open Cloud Alliance, where BU and Harvard are helping to operationalize an on-premise hybrid cloud to support MOC development activities, but also support researchers that require cloud resources going forward. We also work very closely with the Office of Research in the BU libraries. So notably, recently, the three offices worked closely together to really disseminate knowledge on NIH data management policy changes that were coming about. So we did a very effective job in communicating to the research community about that. And then also we work with other administrative units in the university. So analytical service and institutional research. we worked really closely with them in conjunction with researchers during the pandemic. So the university needed to do a lot of COVID modeling. So modeling how COVID may spread at the university and making sure that there were enough quarantine and isolation spots available for students that may have gotten sick during the pandemic. So that was all done on our cluster, and we played a key role in developing the workflows and algorithms around it. Outside of VU, as Jana said, VU is one of the founding members of the Massachusetts Green High Performance Computing Center. So this is a LEED Platinum facility that is in Holyoke, Massachusetts. And the other members are Harvard University, Northeastern, MIT, and UMass. And the data center is dedicated to research computing. So essentially all 5 institutions have placed all of their research computing resources in this one building. It's been very effective. We've been in the building for 10 years now, and it really has enabled the amount of growth that we've been able to do over the past decade to support research. And because of that engagement, we have all of these projects in the middle that you see that have been collaborative projects with other institutions. And that includes the MOC Alliance and the related services, the New England Research Cloud and the Northeast Storage Exchange, which I'll speak to in a moment. We also take part in the Northeast Cyber Teams, which is an attempt to really broaden facilitation between students and researchers to help them enable to do their work. And then we also help support the Open Cloud testbed. And then on top of that, we have a lot of national organizations that help support research computing and HPC computing, high performance computing broadly through the nation. And some of those is Access, which I'll talk to later, Coalition Academic Scientific Computation, and the Campus Area Research Computing Consortium. So this chart shows our user base. And back in 2013, when we first moved the shared computing cluster to Holyoke, we were doing about 11 million CPU hours a year, and that was supporting 968 researchers and 38 departments. You'll see here on the left, this starburst essentially shows the number of projects by department, by each college within the university. And during that time, back in 2013, we saw a lot of traditional STEM fields, chemistry, physics, and engineering, but we also saw a lot of growth in life sciences and medicine. And part of that was due to the combining of the BUMC research computing and Charles River campus research computing units together. So we've seen huge growth in that area since. And again, we were doing about 11 million CPU hours and had about a petabyte of storage for research. Now we're in 2022, 10 years later, and the amount of growth in the cluster is grown dramatically. So we're now doing about 100 million CPU hours a year to support research. We support over 3,000 researchers in almost 90 departments in the university. And as you see there, we're also supporting a large number of students, so over 2,000 students in 38 courses. And you'll see that we have a very broad user base that's grown across all of the colleges within the university. And the growing departments are going to be a lot of AI and data science related fields. So computer science, electrical engineering, Questrom. So there's a lot of use of our resources by finance, management disciplines, college communication, and others as well. So we're up to 9.5 petabytes of storage of research data that we support. And we have 20 departments with 20 or more research projects.
Do you have several slides for CDS or not yet?
No, not yet for CDS. Yeah. So, I think that number is actually, I'm sure that number's grown since we first made this slide, for university leadership events. And, the CDS's amount of research has grown on our cluster and also on the MOC Alliance, right? In the cloud resources. So our large piece of infrastructure is called the Shared Computing Cluster. This is essentially high performance computing cluster that is over 1,000 nodes, about 27,000 CPU cores. We also have 290 GPUs in that cluster as well, and a large amount of storage. It supports both batch and interactive workflows. So for a lot of research, you will submit your jobs and they'll wait in queue and run on the cluster, but we'll also support users that need to do visualization and other types of interactive analysis as well. We have over 900 software packages in all of the different disciplines that we support for researchers. And we also offer a really easy way to get on the cluster, which I'll show in a second, and a program where researchers can actually purchase in their own resources into the cluster. So in terms of the type of computing resources we offer, the vast majority are general purpose computing nodes, and those go from 8 to 32 CPU cores per node. We also offer large memory nodes that'll offer up to a terabyte for large data sets. High performance computing workloads, which essentially use a high speed fabric, and you can create a single system image for workloads over multiple nodes. So we'll support up to 448 cores on that. And also a vast amount of different GPUs. I'm just listing a couple here. The most recent ones, we offer A40 and A100s. GPUs as well. This picture is just our support site. So as I said before, almost everything that we do, you can go to our support site and learn about, and there's documentation and training and videos to help aid you in using the cluster. And we also offer what's called the SCC buy-in program, and this is for faculty that want to purchase their own resources and have it managed by our team in the cluster. So for the shared computing cluster, the university provides a subsidized portion of the cluster, which is refreshed on a yearly basis. So essentially central funding comes from the university to allow any researcher to use the cluster. But for researchers that want more dedicated resources, we offer what's called the buy-in program, where they purchase the actual equipment, but we manage the administration and support of that equipment, and the university will subsidize the space, power, and cooling. And in return for that, the researcher will get priority access on their equipment that they purchase, so they'll be able to run quicker and more effectively, but they can also spread their workload across the entire cluster if needed. And unused cycles on those nodes are given back to the general community for all researchers. And this model's worked really well over the past decade. You know, we've had 618 compute nodes and almost 15 petabytes of storage that's just been purchased by researchers. That's not been purchased by users. Here's some pricing in terms of the different nodes that we offer. So we offer, like the resources page I showed before, value node, large memory, GPU nodes in various configurations, which are the most expensive nodes, which is why we don't have a lot of them. And also we offer storage, which is essentially very cheap, $76 a terabyte for the 5-year term. And then in an effort to really make it easy for researchers to utilize the cluster, we have what's called the SCC on-demand interface. And that essentially allows anyone to use their web browser to connect to the cluster and do all the work that they need to do. So in the past, users would have to install programs on their laptops in order to connect to the cluster, and they don't need to do that anymore. Essentially, SCC on demand is taken over that activity for the majority of users. Doesn't require any additional client software, and it's very well suited for interactive applications. So if you're running like Jupyter Notebooks, MATLAB, RStudio, you can essentially log in and click on the interactive apps tab here and start your workload, and it'll come up in the web browser and you can start working.
Question, are there things that you cannot do with a web interface that you can do otherwise?
Very little. So I would say maybe the only thing is if you wanted to do like API access straight to the cluster, right? There's, you know, obviously you'd be doing that from another machine, a client machine, so that wouldn't work within the web browser. But really, for the most part, everything can be done through this interface. Even visualization, where you need to do very interactive visualization of, let's say, fMRI imaging, things of that nature, it's supported through this interface as well. So it really makes it very easy for anyone to utilize the cluster.
Can we take a poll?
Yeah.
How many of you are using the web interface? And how many are still using the old terminal access?
ENC.
Okay.
Yeah, and I don't think we'll ever get rid of the terminal access because there is a class of users that are very, very steadfast in using that, especially from the physics and chemistry communities, right? And engineering communities.
Those engineering.
Yeah, so they're very used to using terminals, and we certainly allow that. We actually put this in production when the pandemic started. We understood that we needed to really facilitate use of the cluster for people from home, and this was the best way to do it. And so it's been fantastic. SEC On Demand is actually a product out of Ohio Supercomputing Center called On Demand, and it's used at a wide variety of research computing and HPC centers across the nation. So it's an NSF funded project that is in continuous development, so they keep adding features all the time. In fact, we're trying to get this ported to OpenShift. So hopefully we'll be able to have it running on New England research projects. And then, as I mentioned before, we have over 900 software packages. If you count all the versions of packages, it's probably in the mid-thousand number of software packages available to researchers. And this is on our support website. You can easily go to this page and search for a specific piece of software that you may need to use. And it'll show the page on the right, essentially a little descriptor, the various versions that are available, how to use it, and details on that package itself. So if there is a software package that you need that is not installed, you can fill out a form and then we will help install it for you. So we try to do central installation of software packages when possible. But you can also install software in your own project space, your own storage space for your project. And then in addition to all of the infrastructure and sort of those service layers, we have a lot of people with domain expertise and backgrounds. These are all the different people in the support and outreach group and our applications group. And they work directly with researchers one-on-one to essentially help them run their code on the SEC, help them develop algorithms, help them develop workflows. And this results in a large amount of researcher consultations. So we do between 600 and 800 researcher consultations a year that we work with the researchers. And these are just the different activities that that group does in addition to consultations, training, academic support, and the code development and workflow. And this is just a background on the different degree areas that these people have that can help. And then we also offer a large amount of training to the community. So we have this is our tutorial room that is attached to our main offices on 2 Cummington Street. And so we offer tutorial series 3 times a year, so fall, spring, and summer semester, in various topics, including just using the SEC, how to effectively use it, math and data analysis, HPC topics, visualization. And we also work with vendors such as like NVIDIA, MathWorks to provide their own trainings as well. These trainings, some are not specific to the SEC. So if you want to learn more about R or Python, we have a whole series of trainings that you can attend to learn about that. And you can just do that on your laptop. You don't even need to be using shared computing cluster for those activities. And a lot of the trainings we have recorded and the slides are available on our support site. So if you can't make a training in person, you can always just go and watch the video in terms of the training and look at the slides as well to help you work more effectively in your research. We also will go in and provide specialized training to individual research groups and labs. So if you're a part of a group that uses very specific packages, say you use R, but you don't use Python at all, we'll actually meet with you, discuss what your needs are, and we'll come in and tailor a training just for your group so that you can onboard more quickly and effectively and work faster on the cluster. And there's a link here that will that'll take you to a page that talks about our training offerings in more detail. And then the other thing, as I talked to before, is supporting academics. So we have an academic support service that directly leverages the SEC infrastructure and support. So all those packages I described, the on-demand interface, all of that can be leveraged by courses as well. There's dedicated computing and storage resources for those courses. So we started out with a small number of compute cores and GPUs. And as you can see, the growth in both students and courses that are using the cluster is climbing at a pretty fast rate. So, we do our best to support all of the students in those courses. We'll install course-specific software, and there's automated management of the accounts. So if you're a faculty member, you just tell us I'm teaching this course in the fall, and then all your students just get created automatically. You don't have to do anything. So it's a pretty easy process. There's a form on our website that we just ask faculty to fill out, and that will help us get your course onboarded quickly. And then we'll also do training specific for TAs and TF, and we'll also do in-classroom trainings. I think did about 50 in-classroom trainings this past year. So we'll actually go in and help onboard students that are taking. Okay, now I want to talk about other engagements outside of the SEC that we're involved in. So a big one is called the Mass Open Cloud Alliance. And the Mass Open Cloud Alliance essentially is there to aid a lot of projects that are doing either development or production of cloud resources, open cloud resources. So these aren't resources that are on your typical AWS or Azure. These are actually cloud resources that are deployed on site. And so the area that we really have a close tie-in is the production cloud services. So we're part of two projects. One is the New England Research Cloud that we're jointly operating with Harvard University. And that's to provide OpenStack and OpenShift resources to the research community. I'll speak to in a second. The other one is the Northeast Storage Exchange, which essentially provides object and tape storage out of the MGH-PCC to the research community. And you'll see some of the other projects that are important. We have a close collaboration with the Red Hat through the Red Hat Collaboratory. It's their product that we're operating on the New England Research Cloud. And so if you have other questions about MOC, there's Michael there. He can help answer them. So in terms of the New England Research Cloud, this is kind of what we started off with 3 or 4 years ago, just before the pandemic began, between Harvard and BU. We both saw a need that there was a growing community of researchers that needed cloud resources, but also acknowledged the fact that getting resources on commercial cloud is cost prohibitive, and it still can be cost prohibitive depending on the type of data that you're working with. And we thought rather than each of us set up our own cloud infrastructures, let's work together collectively in a collaboration to do it. And the aim is to essentially provide self-service, software as a service for easy access, platform as a service, and infrastructure as a service to the research community. And our hope is that we'll be able to have other partners join us, mainly the other MGH-PCC consortium partners in the future, so that we can continue to grow and expand the usage of this service. So this is not just for BU and Harvard, but it's broadly for the region. And then the other important thing is, if we're able to build the New England Research Cloud, can we reproduce it for other sites that want to do that? And in an open source fashion, if I'm a university on the West Coast and I want to do something similar, can we take all of the lessons that we've learned in our process and essentially develop a similar type of solution? So we try to be as open as possible with the code and administration for the service. And then also the facilitation component that I talked to earlier on the SEC is equally, if not more important on the cloud. How do we build a team of facilitators that can actually sit with researchers and help them get onboarded onto the cloud and use the cloud effectively? It's even more important for a cloud than it is for standard HPC and research. So this is sort of a logical diagram of how the New England Research Cloud is organized. So as you see, the MGH-PCC down below is a data center that we spoke to before. And then we also have the Northeast Storage Exchange that sits on top of that. And then NERC essentially leverages both those, right, in terms of the space, power, and cooling and the storage. And what we do is we work very closely with the MOC Alliance that are in Red Hat that are doing a development of services, right? So they're developing product over time. And when those products become mature enough and we want to expose that to the community, we then adopt it within the production cloud service. And on the left side, you'll see the different communities that we want to support with this, and it includes research, which also includes incubated startups out of the universities. in higher education and workforce. And in the middle there, you'll see, can we make this so we have an easy web portal to access the service, which we have now? And can we build a team of cloud facilitators that can work both within our institutions and regionally to help researchers adopt the service? Currently, NERC has about 4,000 compute nodes and 60 terabytes of memory and 8 GPUs, which we're hoping to grow over time. More coming soon. Again, this is kind of the summary of what's provided right now. We offer virtual machines through OpenStack. So we have general compute, memory intensive, and accelerated compute using GPUs. Right now we have 15 investigators, 65 projects from over 7 institutions. And the service that just went into deployment at the beginning of this month is container orchestration using OpenShift. So this is for containerized workflows, mainly Kubernetes, which is growing more and more over time. And so we're growing that service as we speak and hope to onboard more researchers to use that. And then finally, developing software as a service on top of these layers to provide easy access for researchers to use, web-based environments to be able to actually do their analysis. And the first project that we're going to try to onboard is the Red Hat OpenShift Data Science Service, ROADS. And it's a machine learning analytics platform that Red Hat hopes that will be adopted widely by the research community. So that's currently in development. And then just a note on the Northeast Storage Exchange. So that provides two types of services. One is disk service through Ceph. So we can leverage Globus, which is a file transfer protocol to move data in and out. Supports object and block storage, and NERC uses this storage layer essentially for everything that it needs. So the system images for the OpenShift and OpenStack are served out of NESI, as well as the research data that researchers need to analyze. And then the other layer which is currently being defined is tape layer. So this provides inexpensive, high capacity archive type storage for researchers, which is a growing need because the data needs are going through the roof. So our hope is to be able to leverage that service to help store less used data sets by the researcher. And just a sample of some of the use cases that we've helped with. This doesn't include the multitude of use cases that the MOC Alliance has helped support and the SAIL group has helped support as well. So for you to identify here, the first one is the Geographical Accessibility Project. So this is kind of lean the School of Public Health. Essentially, being able to effectively map accessibility to services is important to public health. It's groceries, grocery stores, parks, and et cetera. And what we did is help them utilize the Open Route service. So they're using ArcGIS, which is a commercial product, and hitting limits in terms of the free tier that we use. So we initially implemented the Open Route service on AWS for them to use. And then when the OpenStack service was available, we ported that easily over to NERC, and they're using that now. They're very happy with it. It can be leveraged by other research projects within the School of Public Health as well. Second one here is essentially analytic workflow to help identify candidate cancer drivers. And so our group helped optimize the code and wrote an R package that is being submitted to Bioconductor, which is a large repository of R codes for the life sciences areas, and assisted in porting and essentially publishing an R Shiny app to NERC. So researchers across the world can now access this product using New England Research Cloud. And then the last one is support for courses. So over the fall, we had our first course on NERC, onboarded over 50 students. That was essentially a data science course for students, and we hope to grow this. So there are some cases where resources on SCC or the resources that are being provided by NERC are not enough, and what can researchers do to get their research done effectively? And so we're part of what's called Access, and it's an NSF-funded program that provides the ability to leverage high-performance computing and research computing resources across the nation, including large HPC centers. So essentially, There's also a facilitation layer where, as a researcher, you can put in a proposal to help actually get facilitators to work with you to develop your code. And that would be dedicated time for the researchers. And these are 4 tiers that we have of resources that PIs can actually go for. There's tier 1 through tier 4. And as you go up the ladder in tiers, there are more requirements that you need to do. So tier 1 essentially is, this makes sense to use large resources for, and if so, you can get up to 400,000 CPU hours, or up to 7,500 GPU hours. And then as you move up to tiers for larger awards, you have to do either 1-page, 3-page, or 10-page proposals. On the left here is some examples of systems that are available to the research community. Some of these are cloud resources. Some of these are typical high-performance computing resources. But we also offer, there's also specialized experimental testbeds that are available to researchers. Composable hardware, which is a new area in terms of disaggregating the CPU and the memory and the storage from a computer and tying them together. And then also newer processor technologies or different processor technologies, such as ARM-based technologies and NeoCortex as AI hardware. So accessci.org is the place you would go to for that, but we can also help facilitate access to the resources and help you develop a successful proposal that could be submitted to that group. And then looking to the future, we expect continued growth in new faculty and academic courses utilizing research computing. So I think we estimated over 500 new faculty hires over the next 5 years, and they would require at least half of what the SEC comprised today to support those workloads. So we'll have to continue to grow in terms of hardware and facilitative support. CDS is obviously brand new, and that's going to essentially expand use of computing across all of the disciplines in the university. And some areas that we need to still tackle, increased regulated data and security requirements that go for that. So there's more and more data sets that are restricted in terms of access that we need to be able to support. And as the mass of data grows, how do we manage that research data over time? And then things like MOC Alliance, New England Research Cloud, and Northeast Storage Exchange. Those are all collaborative projects that are supported by the MGH-PCC institutions. How do those develop over time, and does the MGH-PCC actually provide service itself rather than just house hardware from various institutions? And that's it. So I'll take any questions we'll have.
Thank you. Any questions?
Hi, thanks. This is a very thorough and nice talk of the SCC, because I personally and our group has a high node of GPU on SCC, and I use it every day, and I find it very helpful, especially those storage that I don't have to manage on the local computer.
Yeah.
So right now, I think I have just two questions. One is that I found that sometimes SCC can abandon some of the modules. One is that there's one day I log in and I do the normal script, and I found some package missing, and I found, okay, SCC don't have the specific version of Python anymore. Mm-hmm. So is that expected, or?
So no, it's not expected. And when that happens, you should send the email to help at SCC, and we can look into that. I'm going to put a little asterisk on top of that, because over the summer, we need to transition the entire cluster to a new operating system. So right now we're using CentOS 7, which is essentially the free variant of Red Hat Enterprise Linux, and CentOS 7 is being developed into a more of a stream product where releases are made on a very quick basis, and we can't really support that on the cluster. We want something that's more static. So we'll be moving to what's called Alma 8. There's 2 main versions that most of the centers are moving to. During that transition, we will decommission some of the modules. An email was actually just sent out this week to all users that describe the yearly downtime that the MGH-PCC has, that's upcoming, but also the ALMA 8 upgrade. And there's actually a spreadsheet with a list of all of the modules in their current state. So we're currently evaluating some. We will be deprecating some, and a lot of the ones that we're deprecating are ones that have very, very, very low usage. Like, you know, less than 10 people have been using the product over like a year. We want to be very mindful of reproducibility of code. So we want to be careful in terms of, you know, what modules we do retire. So yeah, I would definitely reach out when you encounter that problem. That's not normal, and you know, we can help look into that for you.
Yeah, see, thanks. Yeah, I think this is like, you know, Python has a lot of dependencies,
yeah,
especially of each version, so it can be a pain to transfer.
Yes, absolutely.
Another thing I want to ask is that so sometimes when I access to SCC, especially outside US, it can be very slow. Is there any way to improve that?
Yeah, I mean, it's really hard in terms of remote access to the cluster. You know, when you're on campus, you're still remotely accessing the cluster because it's 100 miles away in central Massachusetts. But you know, we know the pipe between here and MGH-PCC, so we know how well it works. But when you're accessing it from, say, a foreign country, it's very hard to tell whether the issue is with the ISP provider that you're using, or the issue is, you know, with the cluster itself. So again, when you have issues, send an email to us. And if it's something that we're seeing from a multitude of users, then we know that there's probably a slowdown on the cluster, right? And that we need to address it. But we also, I believe, actually have a page that talks about connectivity and different things you can do on the remote side to help improve your connectivity. But yeah, we have essentially researchers access to cluster from all across the world. So it's a big world, and there's a lot of pipes.
See, thank you so much.
Any other questions?
Yeah. Can you access the storage that the specific group has through the web interface?
Yes, there is a sort of a file portion of the on-demand interface that allows a more graphical view of your project space and home directory space that you can actually, you know, use and leverage.
And then you have tools that would enable you to transfer.
Yeah, so typically, you know, it's the on-demand interface will support that through SCP, so typical protocols to transfer data. We also offer Globus, so we have a Globus endpoint on SCC. So if you install Globus software on your machine, that will allow you to move large amounts of data. And let's say your network connection gets terminated, it'll restart the transfer of data, so it keeps track of where that data is for you. We have a page on Globus, and I can send you more information about that. So those are two ways. There's other ones that we've supported in the past, depending on the specifics of where the data is and how it needs to be transferred.
Do you have ways in which data can be transferred from Google Drives or Dropbox into that storage space?
Yeah, we've tried in that area. There are a few sort of command line tools that you can use to get at that data, but we found them to be problematic in the past. So it is a little difficult in terms of from other cloud services that you're hosting storage on to get data back without using an intermediary, right? Mm-hmm.
Any other questions?
Great.
Okay, great. Thank you.
Thank you, and I hope this was useful. And please feel free to talk with me if you have other questions.